Our Earth is a dynamic, ever-changing planet. From the highest mountains to the deepest ocean trenches, every part of our world is in a state of constant flux. While it appears static and unchanging to us over vast stretches of time, its surface undergoes dramatic transformations. Landscapes are reshaped by the forces of wind, water, and ice, carving out new features and erasing old ones. The land masses we know today, the continents, were once arranged entirely differently. They have been on a slow yet relentless journey across the globe. Imagine a time when all the continents were joined together, forming a single, gigantic landmass. This supercontinent, known as Pangaea, existed millions of years ago. This was indeed the case millions of years ago. Fossil evidence and geological formations from that era provide us with clues about this ancient world. The Earth's surface is not a solid, unyielding shell. Instead, it is a complex, dynamic system. It is broken into large pieces called tectonic plates. These plates are constantly in motion, driven by forces deep within the Earth. These plates float on a layer of molten rock beneath the Earth's crust. This layer, known as the mantle, is in a state of slow convective motion. Like rafts on a slow-moving river, these plates drift and jostle against each other. Their interactions can cause earthquakes, volcanic eruptions, and the creation of mountain ranges. This movement, though incredibly slow, is the driving force behind the changing face of our planet. Over millions of years, these processes have shaped the world we live in today, and they will continue to do so for millions of years to come. The theory that explains the movement of continents is called plate tectonics. This groundbreaking concept has reshaped our understanding of the Earth's dynamic nature. It revolutionized our understanding of Earth's geology, providing insights into the formation of mountains, earthquakes, and volcanic activity. The continents we see today, separated by vast oceans, were once locked together in a giant jigsaw puzzle known as Pangaea, a supercontinent that existed millions of years ago. They have been drifting apart for millions of years, and they continue to do so at a rate of a few centimeters per year, shaping the world as we know it. The movement of these plates is driven by the heat escaping from the Earth's core, a process that generates immense energy. This heat creates convection currents in the molten rock beneath the crust, causing the semi-fluid mantle to flow. These currents push and pull the plates, causing them to move, albeit very slowly, leading to the continuous reshaping of our planet's surface over geological timescales. About 300 million years ago, a supercontinent called Pangaea dominated the Earth. All the landmass we see today was clumped together, surrounded by a single enormous ocean. This supercontinent was home to a diverse array of life, from early reptiles to giant insects. The existence of Pangaea is supported by a wealth of geological evidence. Matching rock formations and fossil records found on different continents, now separated by vast oceans, provide compelling proof that these landmasses were once connected. Section 4. Breaking apart, the birth of oceans. Around 200 million years ago, Pangaea began to break apart. This wasn't a sudden cataclysmic event, but a slow, drawn-out process that unfolded over millions of years. As the tectonic plates continued their relentless movement, cracks appeared in the supercontinent. These cracks widened into rifts, and molten rock from the Earth's mantle welled up, creating new crust. Over time, these rifts grew into vast ocean basins, separating the fragments of Pangaea and giving birth to the continents we recognize today. Section 5. Shaping the land. Volcanoes and earthquakes. The movement of tectonic plates is responsible not only for the large-scale arrangement of continents, but also for more localized geological events such as volcanic eruptions and earthquakes. When these plates collide, the immense pressure can cause molten rock to erupt from volcanoes, forming new land. Earthquakes occur when tectonic plates grind against each other, releasing tremendous amounts of energy. These events can reshape landscapes in an instant, triggering landslides, tsunamis, and other natural disasters. Section 6. Life finds a way. The shifting of continents and the geological events associated with plate tectonics have had a profound impact on life on Earth. The separation of continents led to the isolation of different populations of plants and animals, allowing them to evolve independently and diversify into new species. For instance, the unique flora and fauna of Australia are a direct result of its long isolation from other continents. The marsupials, found predominantly in Australia, evolved in isolation after the continent broke away from Antarctica. Section 7, the ever-changing Earth. Our planet is in a constant state of flux, a dynamic entity that never ceases to change. The Earth's land masses are not static, they continue to move and evolve. Over millions of years, these movements have shaped the world as we know it. The continents are still drifting, albeit at an incredibly slow pace, a few centimeters each year. This gradual movement is driven by the forces deep within the Earth. The Atlantic Ocean is slowly widening while the Pacific Ocean is shrinking. These changes are subtle but significant, altering the geography of our planet over eons. In the distant future, millions of years from now, the continents will likely collide again, forming a new supercontinent. This cycle of breaking apart and coming together is a testament to the Earth's restless nature. The Earth's surface is a dynamic stage where the grand drama of plate tectonics continues to unfold, shaping our planet and influencing the course of life itself. From the formation of mountains to the creation of ocean basins, the relentless movement of tectonic plates is a powerful force that drives the evolution of our world.